Hi folks, how you doing? I've been after an oscilloscope for, oh god, a long time now. And it's starting to get to the point where I really need one to complete certain projects. And then you look at the price of them and you think, I don't want to pay £200 plus for something halfway decent. So, rightly or wrongly, I've bought one of these cheapo kits from Amazon. And it's an oscilloscope DIY kit. It was about £20, including postage, I think. So it's a small risk if I bought a load of garbage, but I thought we'd take a look at it. We'd put it together. We'd see how capable it is when it's put together. So yeah, let's have a look at what we get. Oh, let's get it open. So I've got a little LCD screen. Cables. Big bag of components. PCB. And a set of instructions. Awesome. So, it looks like all the surface mount components have already been soldered in. So the ICs and the surface mount resistors, they're already there. So we can get a close up of that. Little focus. There we go. But yeah, everything else I'm going to have to fit myself. And that's fine. I'm up for a challenge. Apparently I must be some sort of masochist, but yeah, there we go. Let's have a look at the instructions. Let's separate out the components. And before we start, let's just make sure we've got everything. Yeah, let's do that. Okay. Yeah, that's a lot of bits. Let's see what have we got. We've got pin headers. Let's put those to one side. Power supply jack. Some ceramic capacitors. So let's keep those separate. Electrolytics. Transistors. Let's just separate everything out. Some tack switches. LED, trim pots. Okay, we're all separated. So what I'm going to do is I'm going to start following the instructions. We'll do this together. And it's going to ask me to install the lowest profile components first, and that is the resistors. So that makes sense. So there's plenty of them, and they're all different values, so I'll have to pay attention to the colour coding. And the colour coding works a bit like that. Well, it works exactly like this, actually. So you've got your coloured bands that relate to different numbers. So you've got your first, second, possibly third digit. Then you've got your multiplier. And then at the end you've got your tolerance. And that's how you work out a resistor value. I was taught a really rude rhyme back in college when I learnt all of this. Which I won't repeat because it's not politically correct in the slightest. In fact, it's horrific, so we won't go there. If you're ever unsure, there are online calculators where you can just literally type in the colours on the bands and it will give you the value. Or better yet, in fact, I would highly advise get a multimeter out and test the components as well before fitting. Never hurts to do that. So I'll probably do both of those. Looking at the resistors, they look incredibly hard to read. They're tiny. So I will be making use of an eye loop, which is something I use for watch repair actually, but it'll come in handy for this as well. Yeah, and I'll be testing them with a multimeter too. So let's start fitting some resistors. Okay, so I've gone through all my resistors and I've labelled all the values. As long as I don't sneeze, I should be okay. I've checked everything's here against the sheet, so everything I was expecting to receive I have. So when I said look through an eye loop and check the colour bands, that was dumb. Don't bother. Just use a multimeter. Honestly, it's far quicker, it's far easier. So, right, these are ready to go on the board now. We're done. They're all in. All the resistors are in, hopefully the correct place. So now all I need to do is flip the board over and solder it all in. Do something about that complete rat nest. Yep, let's do that. There we go. Possibly not my neatest job, but it never is it really? Yeah, resistors are all in, so let's move on to the chokes. Chokes are in, so diodes. So there's two diodes to fit and they are different, so I need to make sure I get them right. But I've just looked under it, some magnification, and that is definitely D1. Making sure I get the polarity right. It really, really, really does matter with a diode. That's that. And number 2, where do you live? Right there. Okay, tack you in. There we go. What's next? Okay, crystal, which I've seen somewhere. I don't think it matters which way these go. So that can go in right there. There we go. Next, USB socket. Note this connector is optional. Well, do you know what? You've given me one in the kit, so I'm putting it in. What the hell? That will go right. If we go it the right way round, right there. Tact switches. Well, they seem to pop in with a reassuring little click. Okay, ceramic capacitors next. So I've got a pile of them. There are a lot of different values, so if you've got one of these kits, just be careful and separate everything out first. Take your time and you should be fine. Yeah, let's start getting these in. Right, half-time update. Where are we up to? So, resistors are all in, chokes are in, ceramic capacitors are in, tack switches are in, USB ports in. What have I got left? So I've got my LED, I've got some regulators and transistors, some electrolytics, I've still got some switches over here, some pin headers. I'm nearly there though. I'm nearly there. And it's going together quite well. All I will say is the board itself has got some very small pads on it. So if you're using a cheap soldering iron or cheap solder, as I am, that can make it a little bit interesting. That's where flux comes in. Flux is your friend when you're soldering onto this. I didn't bother with the resistors, and I wish I had, because it goes so much easier when you do things properly. Yeah, let's crack on. Okay, so this is an idea I shamelessly stole off another YouTuber, but effectively what I've done is I've mounted the screen loosely on the board to make sure that all the pins line up, because effectively what you've got are 3 sockets that you're supposed to solder to the board first. However, if they're out of alignment, then you'll never get the screen to plug in. So I'm thinking, well, the idea was given to me from another gentleman's video. Put the screen in loosely, with the connectors in loosely, then solder it in, and then you know everything's going to line up. So that's what I'm going to do. Right, so I'm basically done, I think. Everything's in place. The ground plane on this doesn't half soak away some heat, so if you're using a cheapy soldering iron like I am, you're really going to need to crank that heat quite high to get things to solder properly. Yeah, I need to clean the underside of that up because it's full of flux, but I think we're there. So following the instructions now, what do I need to do? I need to create a test signal ring. So I need to short out J2. I'll just use a component leg, I suppose. Why not? J2 is up there, so let's just do that. So that goes in there, like that. And let me just get a bit of flux on it as well. Get that tacked in. Okay. Short out JP3. JP3 is right there. Let's do that. There we go. Okay, now I need to check some voltages. So I'll go and grab a 9-volt power supply and we'll see what we get. So I need to connect 9 volts, and I have a 9-volt switching supply here. Then I need to take a voltage reading from test point 22 to ensure it's approximately, and the instructions do say approximately, 3.3 volts. Okay, let's do that. Let's switch into DC. Let's plug this in and hope it doesn't go bang. Nothing yet. Let's try that test point. Okay, so I can take ground off one of these switches, I presume. And 3.35 volts. I'd say that's pretty good. So that seems to be okay. If the voltage is correct, then I need to short JP4 permanently. So let me just disconnect the power and then do that. And then that should be done, I think. Anyway, I'll short this jumper and I'll bring you back when I'm done. Let's put the screen back on, which should all line up. Just about. There it goes. Right. Let's take this tab off. Oh, I love peeling that stuff off. Okay, so let's connect our probes. And let's see if it does anything. I don't think there's an on switch. I just plug it in and it should come on. It's lit up. Booting. That's a good sign. Okay. Well, it's doing something. Let me just zoom in. Yeah. Okay. See if I can get a signal off my finger. Oh, look at that. Well, it's doing something, definitely. I've got it on sensitivity times 1. Set it to 1 volt. DC. Let's try AC. Yeah. Let's get the signal off me. Ground. Presumably just moves it to ground. I should probably read the instructions at this point, but I really want to just press buttons. That's just me. Well, it seems to work. I just need to work out how to use it. There is an instruction manual with it. Apparently, I need to calibrate this, so let's see if we can figure it out. Bum, 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 bum. Connect the red clip to the test signal terminal. Ah, that's the loop we put in. And leave the black clip unconnected. Okay. Let's do that. Yep. It's definitely getting a signal. Select the Send 1 switch to 0.1 of a volt. That'll be that. And the Send 2 switch to times 5. Okay. Set the CPL switch to AC or DC. It's on AC, so that's fine. Adjust the time base to 2 microseconds. Right, so that is... No, that's the wrong way. That's 2. Oh, 0.2. Yep. You should see a waveform or similar. So that's shown in the photos below. And yes, it does match the photos, I can assure you. Traces are not stable. Adjust the trigger level, the pink triangle on the right, so as you get a stable display. Well, that looks pretty stable, so that's fine. 10 C4 capacitor trimmer with a small screwdriver so that the waveform displays a sharp rectangle as in photo C. That looks pretty good as it is. I think that's fine. Set Send 1 switch to 1 volt. Okay. And Send 2 to times 1. Yep. Well, keep all of the settings unchanged. Adjust C6 so that the sharp right angle waveform is displayed. Again, it looks fine to me. I don't think I need to calibrate anything on that at all. It seems absolutely fine to me. Right, so I've been playing around a little bit more, and I've actually got it hooked up to a Nintendo power supply. And I've picked that because it runs on 9 volts AC, and I wanted to see if I could see the sine wave, and yeah, I can. So, it seems to be doing what it should be doing. It seems to be working. I mean, it's a 20 quid oscilloscope. What do you want, you know? If I can see activity on data lines, really that's all I'm interested in, because that's the only use I've really got for it at the moment. Maybe further down the line I can invest in a better oscilloscope, I don't know. But for now, I think this will do. I think for 20 quid, you can't really complain. It seems to have a nice set of features to it as well. So, yeah, we're not quite done. There's another step I need to do. I mean, the oscilloscope itself's done, but I do have this, which is the case. So I need to assemble this now, and then hopefully we can get the whole unit together, and it'll be a finished, done product. So let's do that. So, case, let's have a look. This doesn't appear to come with any instructions, so we'll just have to wing it, I suppose. Let's see what we've got. So, buttons, switches and connectors and screws. Let's separate it out. See if we can figure it out, eh? Good grief, it's kind of a whole MC Escher thing going on there. Right, let's get the protective cover off it first, so we can see what we're working with. Okay, there's that bit. I assume this would be the base, presumably. Do you know what? I'll bring you back when I've peeled all this. This is just killing my back. Right, let's see if we can figure this out. I've peeled all the backing off everything, so I've got a load of pieces that don't seem to make any sense. I'm going to assume this is the base. I've got two of these pieces which are identical, so either they've accidentally given me an extra piece or it's a spacer. They give me this funky thing. Let's see if I can get a good angle on it. It looks weird. It looks to me as if it would go there under the screen. In fact, you know what? I'm going to try that first. So let me just ground myself. Let's try taking the screen off again. Try not to bend any pins. Okay. Will this... Not quite. But it looks like it should fit. But what's holding it up? Right, so I've had to bend a few of the ceramic capacitors down, but it seems to actually fit on there, so I think it is correct. I just want to make sure I'm not straining any components, so just give me a second. I think I need to space things out a little bit, so I think the screen will sit on top of here. Screw in, then the whole module will plug in like that. I think it would make sense because I've got these little screws, so let's try those. So if I plug this back in, Right. Yeah, let's try that. And that'll give me an idea of the spacing I need. Is that already snapped? Looks like it has. That's incredible. Well, all I can say is God bless more competent YouTubers who've already put this together. So I was right so far. I do screw the screen to this. I do fit it as I have. I now need both of these identical pieces, which are spacers, and they go over the top like that. And now I can insert my buttons, so they all fit in. I need my switches. Make sure they engage properly. I seem to have an extra button and an extra switch. I'm not going to complain. It's always handy to have spares. Or I've built it wrong and I shouldn't have anything spare. So now I can put this piece on, which is going over the top of everything, and that'll protect the screen. Make sure it all lines up. Get in. Yeah, the buttons are going to be fun to line up. Hang on. But let's try doing those first. There we go. They're clicked in, and yep, there we go. So that's the top of it assembled. So now if I put the screws in, but I need to put a nut in between the acrylic and the board. So let's just do that. In fact, let's get all four in and then we'll crank it tight. Okay, I'm going to nip them tight and then we'll continue, but I'm going to have to pause because my battery's about to die, so bear with me. Right, I'm back after a battery charge, so apologies for that. Let's get this thing put back together. So I've screwed the first set of nuts up to hold the top of the case in place. I've left the back a bit loose because what I want to do is I want to get this back piece in. And I just want a little bit of play. So it'll fit. I think that's the right way. There we go. Now we can tighten it up. 4 more nuts that go underneath hold the board in place. That'll just about do it. So now we can put the edge pieces on. Right, so I've had this a day or so now and I've had a bit of time to play about with it, and do you know what? It seems to do everything it's supposed to do. I've currently got it hooked up to an Acorn Electron power supply so I can look at the waveform, which is approximately 19 volts AC, although it's unloaded so it's a little bit higher, and you'll see it does slightly disappear off the scale and there's not a lot I can do about that. I mean, you can move the scale up and down, so it's not a problem. Sorry, you can move the waveform up and down. So there are some limitations. In fact, I'll tell you what, I'll put the specifications on the screen now, somewhere. Should be somewhere here, if I get it right in editing. Anyway, do you know what? All I need an oscilloscope for is occasionally to look at data lines. I've got a disk drive I want to calibrate. Nothing too in-depth, really. So I can't really justify spending £200-300 on a really expensive oscilloscope. So I'm hoping that this will just do the job for me. It's 20 quid. It seems to do everything it's supposed to. For £20, it's got an awful lot of features as well. I've got to say, I'm quite impressed with it. It seems to work perfectly. You know, for the amount of times I actually need to use an oscilloscope, this is probably going to be more than adequate for that, and you can't argue with the price. Putting it together, yeah, I mean, it was like a best part of a day's work. I was taking my time with it, plus I was working around the camera while I was doing it as well, so if you're a halfway competent hobbyist, you should be able to do that a lot quicker. And it's fun to put together. Just a little bit long. It just takes a little bit of long time, but take your time with it. Measure those components before you fit them and make sure you're putting everything in the correct place. And you should be fine. Do you know what? I'm happy with it. I'm going to need to live with it for a bit, I think. So this will probably appear in a few more videos as I'm repairing some retro equipment. And then maybe I'll come back to it after a few months and I can give you a more in-depth evaluation of how it performs then. At the moment I can't really do that because I've only just built the thing and I've not actually had to use it for anything yet, but that'll come. Anyway, I hope this was helpful in some way. Thank you for watching and I'll see you on the next one. Bye.